My name is Mike Bernard. I worked in agriculture since 1983, and the first place I worked had a drip irrigation system, so I've been working with drip irrigation systems for about 35 years, sad to say. My partner in crime is Gary Briggs, my partner in this
fabulous endeavor.
And he'll give a word about his experience.
Sure. I'll stand up because you're standing. And maybe we're recording.
And you can get in the frame. How about that?
I can get in the frame. Can you see me?
And Tara can get in the frame. There we go. Now we're talking.
So, my name is Gary Briggs. I was a professional hydrologist for a number of years. I have a history of working on agricultural projects back in, I guess about 1985. I designed and built an irrigation system for Bowden Federal Penitentiary in Alberta, and I did all of the design myself because I had been trained as an agricultural engineer.
For this one, it says rainwater harvesting. That'll get you where we're going to go. So we're going to talk about why we would want to harvest rainwater. Like, why go to all that effort? Our system is going to cost us probably around $10,000 by the time it's said and done to water 10,000 square feet, which is not a lot. And you think, wow, that was a lot of money, but we get side benefits from it. So, quick outline, why do we harvest rainwater, how much rainwater do we get, and how do we go about designing a system. So this first presentation is kind of an overview of why you harvest rainwater and how you kind of get started, what you need to think about before you even get started, because there are things you need to think about. So why harvest rainwater? Obviously decreased storm runoff. You can see here, those runnels in a field are not a good thing for a farmer to see. And that happens all over the place. In our case, the water coming off our barn, our 5,000 square foot barn, was eroding the foundation. So we had to put up eaves troughs. And we thought, well, as long as we're going to put eaves troughs, why not just pour the water into the home where we can use it? So we're decreasing the erosion by doing that. Decreases pollution. What it does is it prevents runoff from your field. And if your field has, even if you just use manure on your field, if you have below the surface runoff, all the nutrients in that manure are now down in your neighbor's field over here. And if you're doing things, if your neighbors upslope from you are doing things like spraying pesticides, some of those pesticide residues can get washed into rainwater and carried for miles and miles and miles. So if you harvest that rainwater and prevent it from washing over land like that, you decrease the pollution source to street water, which is really important. It also decreases the demand on municipal stormwater management. So the city of Ottawa has ditches and culverts and all kinds of stuff like that to manage the water coming off the roads and off fields and stuff like that. So if we divert the rainwater coming off our barn from going in the ditches, we're saving the municipality a certain amount, like maybe a penny, from their ditch maintenance budget. But it is important. One of the other big reasons is to conserve groundwater. Groundwater conservation has become very important. If you think about places like California, they have managed to reduce their water table from about 150 feet deep to over 1,200 feet deep. They have to go down to 1,200 feet now to get water that they can use because they've been pumping more out than goes in. And I think Gary said that water infiltrates into the ground at about a foot per year. So our well at home is 30 feet deep. That water takes 30 years to get down there. So if you figure they drop the water table in California 900 feet, it's not going to come back next week. So conserving groundwater is really important. The other thing that not throwing the water and not allowing the water to sheet across the field like that is done, if the water actually infiltrates into the ground, you're recharging that groundwater system. So you're putting water back into the system instead of taking it out. One of the side benefits for places like the museum here, where the well water is not of high quantity or quality, is that we can use that rainwater to dilute the the well water so that it doesn't prove to be a problem for the plants. There's the issue with the museum is salt content in the well. No, from the ground.
It's nitrates.
Is it nitrates? Oh, okay, that's even worse because that's a groundwater pollutant that comes from people putting too much manure on the property or too much fertilizer. Nitrates are really mobile in the soil. They wash out every year. If you have leftover nitrate in your soil in October, by April it's a problem. The other two nutrients, phosphorus and potassium, will stay in the soil. Nitrates are gone. Anyway,
What about the hardness? Is that bad for plants or is it bad?
It's
Okay?
some, if you're trying to grow cranberries near hard water, forget it. Because they like acid soil. And hard water is sweet, it's basic. It's a pH above 7. Because it's the calcium that makes it hard. And it's the carbonate that's attached to the calcium. The other half of the molecule that makes the water hard. It's calcium carbonate, which means
Right.
that's scum, right?
Yeah.
So it's the carbonate that increases the pH of the soil. It's not the calcium part, it's the carbonate part. So that's what makes your soil pH high. Soil at our place has a pH of about 7.4. In BC, where I've done most of my farming before I came here, the average pH of the soil is about 5.5. And we used to put on limestone, literally tons of limestone per acre to get the pH up to 6.5 to 7, which is where most plants like to grow.
Because I'm thinking about our well water. We used to have a swimming pool and we fill it with the well water. And it was always very low pH. I had to add uric acid all the time.
That lowers the pH. Uric acid. Acids lower pH. Lower the pH.
Backwards, sorry.
That's okay. And questions are good. That's what we're here
Yes.
for. So one of the things that we do, or we can do, we'll have the capability to do, will be to use our 2,000 gallon tank hiding out there. We can fill it with the well water, and we can do that by just having it dribble in very slowly, like if it goes in at, say, 1/4 of a liter per minute. A cup of water every minute that you add to that tank. Over the period of a couple of days, we'll fill that 2,000 gallon tank. And we can use that if we don't get any rain to water our garden. If we do have rain, we can use it to dilute the nitrate out of the water. So it's a side benefit. That's not really why we decided to do it. But if you have that big tank, you might as well keep it full. So, how do you figure out how much water you're going to be able to capture? Environment Canada does that for us. It's really quite simple. They have pages, and there's references that I can supply, or if you go on to Environment Canada, and they have these graphs, and it's how much rain comes up, falls out of the sky, in your location. The nearest location to us is Kempville, and it's pretty good. So we can use these to get how much rain we can expect. As it turns out, to grow good crops, you need to supply crops with about 1 inch of water every week, as a ballpark. As it turns out, in Eastern Ontario, we get about 1 inch of water a week out of the sky. Unless it's like last year, in which case you get 4 inches of water out of the sky in about 6 minutes, and it all runs off, and then it's dry for another 4 weeks till you get another 6 inches of water out of the sky in 5 minutes, which also all runs off. So this is all, it's all, averaged and everything, but that's why you don't see a lot of irrigation in Eastern Ontario. When I was working in BC, every place I worked, every place I drove by had irrigation. Because even though it's wet there in the winter, the summers are very dry. So one of the things that is really nice about the metric system is that all the values are totally interdependent. We have a 1,500 square meter catchment area, the roof on our barn. No, that's not right. 500. So we have a 500 square meter area. If we get a millimeter of rain falling on 500 square meters, we get 500 liters of water. It's a really simple calculation. So we do most of the figuring for the amount of water we get. We'll do it in metric because it's so easy to figure out. The slope of the roof has very little to do with how much water you collect. If you have a peaked roof like this, or a relatively flat roof like that, you're gonna get the same water, the same amount of water, because it's the square footage that counts. So really, the roof slope doesn't matter at all. What is important is the roof material. If you have a steel roof, you throw away less water because it's not as dirty. We'll talk about that. We'll talk about that a little bit later. There's a system called the first flush system. So when the rain starts and your roof has been dry for a week or two, and there's leaves in the gutters, and the squirrels have been running over the roof, and the birds have been flying over the roof and leaving things behind, you don't want to use that water. You want to throw out the first little bit of water, and we'll talk about that a little more later. And the amount that you throw out really is dependent on the roof material. If you have asphalt shingles with the little bits of sand on them, stuff really clings to that, so you have to throw out more water. If you have a steel roof like we do, not much sticks to it. So the first little, you throw out much less. You throw out about a quarter of what you would throw out from an asphalt roof. So it affects how much you lose through your first flush system, but it doesn't really affect how much you get overall.
So Mike, you're just talking about piping and stuff, not rain barrels.
No, that's exactly right, because we're talking about storing thousands of gallons.
Right, okay, because
If we get-
I've always rain barrels and I've never not used any of the water, so.
Yeah, oh no, and
Okay.
if I'd had my druthers, our tank, which is 2,000 gallons, gives us one irrigation. If I had my druthers in a beautiful world where I had an extra $5,000 to throw at it, I would put another tank in. Because I don't trust, I've farmed here long enough, I don't trust the rain to fall out of the sky. And I think one irrigation cycle might not be enough. That's why we're putting in a make-up water system using the well water.
The rain barrels, though, the museum, like on this building, there are 4 rain barrels. And the rain barrels get used quite a bit. We'll have kids come with watering cans, so that if the kids want to water the garden, they can get some water out of the rain barrel and not leave a hose running that's going to run during the overnight. And so rain barrels are perfectly fine for small watering jobs.
But the reason you need to flush it is because it's not gonna go through, it's gonna gum things up, is that why? Because I've seen the
Yeah.
rain barrels, we never not use, there's no water we don't use, we've never flushed it for, and it comes off the roof, or
Yeah.
the eaves drops into
But
it.
it probably goes through a screen on top of your rain barrel.
Yeah,
Yeah,
so that's, okay,
it's essentially the same thing.
okay.
The first flush system does essentially the same, except
It's a
it'll
good-
take out the bits of bird leavings, which are the really important thing. If you're gonna store the water for a long time, if it's, a bacterial soup,
Right,
you probably don't wanna be rinsing your carrots in it.
sometimes the chipmunk, I put it in the pond, but sometimes the chipmunks get into and then
Yeah.
will things up.
Oh, yeah, no, yeah.
What can you do?
What can you do?
Nature. Things.
So like I said, Canada has done most of the work for us, and we can find out how much water we need. It's just a matter of getting it from where it falls off the roof to where you want to keep it. So some of the things you need to think about from a 20,000 foot level when you're looking at designing a system, how much water can we get off our roof, and in practical terms, how much can we store? So if we can harvest 6,000 gallons of rain off our roof, but our tank is only 500 gallons, it doesn't make much sense. You want to kind of match the two up. The location of the infrastructure, so you have to have a tank. This is a fairly good sized tank, ours isn't quite that big, but they can be enormous. So you need to be able to figure out, okay, where are we going to put the tank? Where are we going to put the pump? How are we going to run all the plumbing to get the water from the tank to the garden? You have to figure all that kind of stuff out. The end use of the harvested rainwater, in some places, not in Ontario, but in some places they're actually allowed to harvest rainwater and use it for potable use. So you can actually drink it if you treat it properly. So the end use matters, because if you're going to use it for potable use, you have to have a way of disinfecting it. You have to have a lot more diligence in maintaining it. It's a lot more work. And as I say, you can't do that in Ontario anyway, so we will mention it a couple more times as a sidebar, the use for potable
There's
water.
some states where they're not allowed to save their rainwater. It's against the law.
That's a very big urban myth.
Yes, I've got a lot of people on Facebook, farmers. and
Facebook, I
groups that-
get no
I know, but the
information
groups that
from
I belong,
Facebook.
so there's
Yeah,
people
no,
talking.
but I'm saying that is
about-
a myth. That's an absolute myth. 100%.
I'm gonna throw that out there, so we can.
I'm pretty sure.
Put it back to them, because I mean, these people are talking about their experience, saying we are not allowed to keep our rainwater.
Yeah.
It happened in Bolivia.
Oh, well, that was a
Yeah.
different thing, yeah.
They're probably watering coca plants with it in Bolivia.
Hmm?
They're probably watering coca plants with it.
No,
No, they
they
had-
turned over the water systems to private companies.
Oh,
They
yeah.
had a war and people died.
The other things you have to worry about is municipal regulations. In our case, we had to build a building around our tank because we didn't want it vandalized. So if we wanted to make it more than 99 square feet, we had to apply for a building permit. So ours is 99 square feet. Very simple. You do have to worry about zoning and setbacks. So if you're putting it in an area that's zoned residential, people might jump up and down and throw things at you, and you should probably talk to the municipality. And certainly setbacks from side yard and rear setbacks. There's regulations that say you can't build anything within, I don't know, whatever the setback is, 3 feet of the property line or something like that. So those regulations are going to exist, and you have to talk to the municipality and find out what exactly the regulations are in your area. One of the things you have to worry about is overflow water disposal. So what happens if it rains tomorrow and we get 2 inches of rain and the tank fills up, and it rains on Tuesday and we get 3 inches of rain? You now have 6,000 gallons of water you gotta get rid of. So that's one of the things you have to worry about. Intensity, duration, frequency, that comes with the previous slide where we talked about the amount of available water. If you have one rain event a week that is 6 inches of rain falling, in a big thunderstorm, and that's all you can expect, you might have to design your system to get the water from the roof to the tank differently than if you get, like they do in BC, where you get a steady rain for 6 months, but it's falling at 1 inch a day. That's not really a big issue. So the intensity, duration, frequency are important. The other thing is there are incentives. There's grants, there's tax rebates. The city of Ottawa has a program for installing rainwater harvesting. Guelph will give you up to $2,000. The city of Guelph will give you up to $2,000 to install a rainwater harvesting system. So there's that, and that takes a little bit of poking around to try and find those grants, but they are available. What else have I got on my cheat sheet here? That's it. So that's the first presentation for the most part. There's a few tools for design. One of the things that I'll refer to frequently is a book called Guidelines for Residential Harvesting Systems Handbook. And just hang on a second, if I can demonstrate my mastery of this, I can go over here and do like this. So this is the book that CMHC has put out, and this course is based on this book. This is 138 pages, of which 6 pages are useful. So we're going to tell you which 6 pages to look at. Actually, not. This is a really good resource, but it's full of stuff that's incomprehensible.
And written by lawyers.
Written by designers.
Yeah,
So there's engineers, yeah, exactly. So there's lots of stuff like this. If you have 4-inch K-style eaves troughs, what does that mean? I have no idea. So we read pretty much, I skimmed the whole article. I have to admit, I skimmed the whole book, but the index was very helpful to get to the pages you want. And there's really good information from it. This is designed for people who, like you, have absolutely no experience in designing a rainwater harvesting system. If you can read that book and understand it, you'll be able to build it. Or you can just come to a seminar like this and I'll explain it all in 2 hours and you'll be ready to go. So that's the first presentation.